Today I'd like to introduce you to augmented reality, mixed reality, virtual reality, and extended reality. I will explain what each one is and what products are associated with each technology. I will also cover some risks and roadblocks. Welcome to AR, MR, VR, XR technology with Tess McKinney at XRenegades. Hi, I'm Tess McKinney, and I'm the owner of XRenegades, a sub-company of Firework Media Studio, LLC. I'm a consultant from Nebraska who has 20 years of experience in technology and 7+ years of experience in immersive technologies. I hope you enjoy the presentation today. Augmented reality is the real-time use of information in the form of text, graphics, audio, and other virtual enhancements integrated with real-world objects. It is the real-world element that differentiates AR from virtual reality. In the AR experience, you can see a composite view of a physical or real-world element and a digital element. However, there is no interaction between the digital element and the physical world elements. The ability to overlay digital objects onto the physical world is revolutionizing many industries, such as gaming, education, healthcare, and manufacturing. I am now going to show you an example of augmented reality using my phone. I have downloaded an application called Blipper, which is an augmented reality app in which you can assign codes with special objects that are embedded on real-world items. Example here is a Christmas card I did a while back. You can overlay anything you want, including video, audio, interactive tools, and 3D objects. In this example, I overlay a video I created with audio over the picture of my family's barn, thus making the real-world object interactive. This is a free application, but there are many applications out there that are specifically created for each industry. Mixed reality, or MR, is a technology that allows not only the superposition of digital elements into the real-world environment, but also their interaction. In the MR experience, the user can see and interact with both the digital elements and the physical ones. Therefore, MR experiences get input from the environment and will change according to it. Mixed reality is similar to augmented reality, as it won't remove you from your surroundings, but rather read your surroundings and add digital objects to your environment. Both augmented and mixed reality have similar products. Imagine a manufacturer of construction equipment, tools, or structural materials used in the development of a building. Using an iPad in front of construction equipment being designed where they can see virtual specs of the design and also see how it could function in the real building. The challenge is that these technologies require heavy doses of data, the ability to process vast amounts of data at impeccable speeds, and the ability to scale projects in a computer environment. Immersive mixed reality requires a precise and persistent fusion of the real and virtual worlds. This means rendering complex models and scenes in photorealistic detail, rendered at the correct physical location with respect to both the real and virtual worlds, with the correct scale and accurate pose. This is why mixed reality tends to be more expensive. Mixed reality works with the help of cloud computing and artificial intelligence. An MR device processes and stores data in 3 dimensions using powerful AI sensors, lenses, a graphical processing unit, or GPU, as well as graphic cards and core chips. Examples of mixed reality headsets include Vuzix, Microsoft HoloLens, Magic Leap, Lenovo, and Google Glass. I'm going to show you short video snippets of a few of these so you understand what they do in the commercial world.
Companies were using glass. So we had to check, did it give them headaches? Did it overheat? Was it ergonomically safe for our employees to put the product on and use it for an 8-hour shift? From there, we realized that some of the information we were putting in to the quality checklist, images, pictures, things they could see of what it was supposed to look like, are the similar things that the assembly team needs to see on a regular basis. So now we're doing standard work instructions in our operations through glass for all operators.
Someone who has the same machine in Germany and has 10 more years of experience with it, you can figure out problems way more faster.
I saw items that I've spent hours on building come into a real-life environment, and I was able to manipulate those and change those to reflect the environment that they're in. That was a great planning tool.
Factory worker knows and the new employee. When we train our new employees, we break down complex operations into specific tasks. We take these tasks and we load them into a tactile manifest, which is our instructions. When a new employee starts at PBC Linear, more often than not, they're putting on an AR headset for the first time. When we put the Magic Leap headset on our new employee, it's a comfortable, exciting experience for them. They know they're dealing with a new technology that is just around the corner. Also, after they see that they are simply executing a series of instructions that's on the headset.
What is virtual reality? Virtual reality, or VR, is the name for computer technology that makes a person feel like they are somewhere else. It uses software to produce images, sounds, and other sensations to create a different place so that the user feels like he or she is really part of the other place. The more deeply users can immerse themselves in a VR environment and block out their physical surroundings, the more they are able to suspend their belief and accept it as real. There are 4 kinds of VR: non-immersive, semi-immersive, fully immersive, and collaborative VR. I will now tell you about each. Non-immersive. This type of VR typically refers to a 3D simulated environment that's accessed through a computer screen. The environment might also generate sound depending on the program. The user has some control over the virtual environment using a keyboard or mouse, but the environment does not directly interact with the user. A video game is a good example of non-immersive VR. Semi-immersive VR is a type of VR that offers partial virtual experience that is accessed through a computer screen or some type of headset. It focuses primarily on the visual 3D aspect of virtual reality and does not incorporate physical movement in the way that full immersion does. A common example of semi-immersive VR is a 360 video or photography tour. Fully immersive VR. This type of VR delivers the greatest level of virtual reality, completely immersing the user in the simulated 3D world. It incorporates sight, sound, and in some cases, touch. There have even been some experiments with the addition of smell. Users wear special equipment such as HMDs, helmets, goggles, or gloves and are able to fully interact with the environment. The environment might also incorporate treadmills or stationary bicycles to provide users with the experience of moving through the 3D space. Collaborative VR is sometimes cited as a type of virtual reality. In this model, people from different locations come together in a virtual environment to interact with one another, with each individual represented by a projected 3D character or avatar. The user typically communicates through microphones and a headset. Next, I'm going to tell you about virtual reality headsets and which companies support these applications. What is a VR headset? A head-worn apparatus that completely covers the eyes for an immersive 3D experience, also called VR goggles. VR headsets may be entirely self-contained, such as the Meta Quest 2, or the HTC Vive, or the Pico. These headsets will cost anywhere from $400 to $1,500 each. Here are some examples of virtual reality headsets: Oculus Quest 2, N Pro, HP Reverb, HTC Vive, and Pico XR. There are many more. I'm going to show you short video snippets of a few of these so you understand what they can do for training in the commercial world.
Welcome to the Occupational Safety and Health Training. This training is dedicated to such important topics as maintaining safety at the workplace, helping now dielectric gloves.
Extended reality, or XR, is an umbrella term that encompasses any sort of technology that alters reality by adding digital elements to the physical or real-world environment by any extent, blurring the line between the physical and the digital world. There are many risks and roadblocks to consider when choosing an immersive technology. First, comfort. You must take into consideration that the user may be wearing the headset for an extended amount of time. This may cause issues for the user in their everyday tasks. You may want to limit the amount of time the worker spends in the headset. MR glasses, or mixed reality headsets, are often lighter and can be used for longer periods of time, depending on the kind of MR headset you go with. For example, HoloLens is heavier than Vuzix. Some are attached to safety glasses, while some are a full headset. VR headsets can be worn for the appropriate amount of time to go through a training. Normally not more than 40 minutes is recommended at one time. These headsets tend to be a little bit heavier and fit completely over your eyes. Affordability of the headsets is another risk. While most headsets have consumer versions at a lower price, some are still very expensive per person. For example, mixed reality headsets such as the HoloLens can be priced anywhere from $3,500 to $4,500 per headset, while the Vuzix is $1,000 to $1,800 per headset. Virtual reality headsets are cheaper, such as Oculus Quest 2, which is $400 to $500. You'll also need to remember that these prices are strictly for the headsets. To create software for these headsets can cost anywhere from $2,000 to hundreds of thousands depending on the product you select, or if you're creating it custom. Consumer applications that are already made can cost anywhere from being free to hundreds of dollars. Sanitizing headsets between each user is important, especially if you are in a sterile environment or need to switch users throughout the day. There are a few ways to do this, either by using UVC lighting or by simply wiping the headset faceplate with Clorox wipes. Some headsets also have disposable VR faceplates called VR covers. You can use any of these options. Depending on the headset, they all have different amounts of times they can hold a full battery charge. Some have extended batteries that you can attach to the headset to make the charge last longer. Most hand controllers require a type of AA or AAA battery, depending on the headset. I'd recommend getting the extended battery pack if you want it to last more than 2 hours. Most headsets last anywhere from 2 to 6 hours, while extended batteries can last up to 16 hours. Another thing to think about is connectivity. In the case of the mixed reality headset, they need to be completely connected at all times to an internet connection via Wi-Fi, so that it can constantly engage the data set it is supposed to be working with to deliver live information and interactions. While VR headsets may need connectivity based on the software application, or if you're using collaboration VR, some applications do not require Wi-Fi in order to interact with the training application. In those instances, no Wi-Fi is required and the headset has a standalone application. I would like to thank you for taking the time to listen to my presentation about augmented, mixed, virtual, and extended realities today. Please contact me if you have further questions regarding these immersive technologies.